first one is the Conference of the Parties, COP. This is the specific meeting to reach the agreement at the United Nations Framework Convention on Climate Change. And this is COP is where the country representative around the world who comes to access to negotiate the agreement and to find a solution to address the problem of climate change. And so far, the most effective and the most well-known COP is COP21. It took place in Paris 2015, and the result of the conference was a new international agreement on climate change to keep the global warming increases below the 2 degrees Celsius and aiming for 1.5 degrees Celsius. Okay, this is 2015, and 2000 now we have another policy, international climate policy called Global Methane Pledge, where about 157 countries participate in the Global Methane Pledge, including the rice-growing country, for example, Vietnam, Philippines, and Pakistan. And in this Global Methane Pledge, the action needs to the address is on methane emissions that need to be happened before 2030 to keep the target of Paris Agreement. Also, when we talk about the national communications or inventory, we will follow the IPCC guidelines. So the national estimates are part of the national communications that every country that agree on the Paris Agreement has to submit to the United Nations Framework Convention on Climate Change, or UNFCCC. And emission factors are needed for computing the total emissions from the country using the IPCC guidelines. And this is what I found from the internet, the national communication of Pakistan for 2018. And I zoom in the data of rice cultivation in the agriculture sector is contributed about 3% of the emission from agriculture sector of Pakistan. So we talk about emission factors. So what is emission factors? This is emission factor is the amount of greenhouse gas emissions coming out of a source. For example, the amount of methane from a given the amount of methane from rice production given in a unit of kilogram methane per hectare per day or kilogram per hectare per seasons. And an emission factor is an average of all estimates at one location and one baseline management. We say here about continued flooding. For example, the emission factor for rice with continued flooding in Okara, where we have our experiment now. Whereas another factor we call scaling factors is the relatively change due to the management practices at one locations and one seasons. Let's say we have an experiment with continued flooding, another one with AWD, and in the end of the seasons we see, okay, we have 50% of the reductions, and that the mitigation potential is 50%, and the scaling factor is developed by the ratio of AWD and CF. So we can say if 50% of the reduction, the scaling factor will be 0.5, whereas AWD scaling factor for given by IPCC now is 0.55. According to the IPCC, for national greenhouse gas inventory, there are different tiers, and I will go to the very basic to to advanced. So we have 3 tiers: Tier 1, 2, and 3. So Tier 1 is the basic approach that the country use the countries use default emission factor given by IPCC. It is now 1.19. And of course, when globally use of one emission factor is we will expect to have high level of uncertainty. That's why most of the country now they use the tier 2 approach, where the report based on the national or subnational emission factors and the disaggregation of activity data from crop management. Tier 3 approach is the most highest tiers and also complicated one. It requires a validated simulation model and require detail of activity data, soil data, and climate data. And let's say if all the requirements met, and we can expect to have the lowest level of uncertainty. So tier 3 approach will be given in detail by Dr. Radha Nelson later on. So, so this is how the national estimation of emission will looks like. So we have tier 1 approach. We use the emission factor from IPCC, and this is the baseline crop management with continued flooding and no organic amendment. Then we need the activity data, and this for tier 1 approach we can use some statistic data of the national rice area per seasons in a given year, and we also need the cultivation period. After we have the emission factor and activity data, we can estimate the total emission of the country, and this one can be put into the national communication, and then of course it can be regularly updated for the national inventory in the next round. For tier 2 approach, of course, it's the same way how to estimate the emission, the total emission, but as I mentioned earlier, we have tier 2 approach, and we need the country-specific emission factor, and where it comes from is from the field measurements for sub-regions or seasons if we have different seasons in a year. And we need the activity data, but it's a little bit the activity data for tier 2 approach require more detail of the crop management practices, and the statistic may not provide enough detail that we need. So usually what we did is we do the data mining from farmer surveys or remote sensing to know the water management practices, for example. And then the procedure for emission estimation is the same as tier 1 approach. Because I mentioned the measurement, so this is how it looks like for in different research groups that we conducted the experiments. We can see different design of the chamber here, according to so from 2014, 19, 23. So we developed the chamber according to what availability that in the country that we have. Another approach that we are using at IRRI now, we use the chamber also, but instead of having the gas injected into the vials, bring it into the lab, we can have the real-time measurements in the field now using the laser-based analyzer. And the response time of this measurement is every 2 seconds. You can receive the signal, and this can be detected methane, nitrogen dioxide, carbon dioxide, and water vapor. And this one is very high mobility at the field scale. We can also measure greenhouse gas emission in the rice field without using chamber. This is the eddy covariance technique, and I think few of you can know that in Okara we have one station of eddy covariance there. Okay, so as I said earlier, I give a case study in Vietnam. So this is, so for those who are not familiar with Vietnam, Vietnam is located in the Southeast Asia, and we are one of the biggest rice exporter in the world. So, and in this study, we focused on the Mekong Delta. Is located in the southern part of the country. It's in the lower part, there, and at that point, 2018. So we didn't have many of the data going on. So we have one project called CLUES, this from Erie, and we conducted experiments from different agroecological zones of the Mekong Delta. We have alluvial zone, saline zone, deflooded zone, and acid surface soil zone. So we have different factors for different agroecological zones in the Mekong Delta in 2018. 2 years later, more and more data comes from across the whole country. So we have 36 field sites and 73 seasons from the north, the central, and the south of Vietnam. So we developed a very detailed emission factor for Vietnam. And this one is already published 2020. So we expected that we can use it in our next national communication. And this is how we went through the process. So for the national communication, the second version, the second national communication 2012, 2010, we still use the default value. And then after that, a few years, the third national communication, we apply already the Tier 2 approach, and we expect that our detailed emission factor will be used in the fourth coming national communication. So I go to the conclusion. So the greenhouse gas inventory are parts of the national communications, and it have evolved as a key document for defining the climate policies. For example, the mitigation targets in the nationally determined contributions. And at this point, most of the rice growing countries in Asia, in Southeast Asia, apply Tier 2 approach based on country-specific emission factors. And the IPCC guidelines defines the standardized procedure for national greenhouse gas inventories, but also it allows some flexibility for the government agencies in different countries. So